After the definition of acceleration due to gravity, which is denoted by small g, now I want to present another matter. This is the dependency of small g. I mean to say, what are the factors which affects g? Let's talk about this. Value of g depends upon, number one, radius of the earth, which is denoted by r. It also depends upon height from the surface of the earth, which is denoted by small s. It also depends upon depth from the surface of the earth, which is denoted by d, and it also depends upon rotation of the earth. Now I want to talk in detail about each of them, especially about number 1 and number 2. Do you know that earth is not a perfect sphere like a ball? It is somewhat flattened at the pole and bulges at the equator, like this. It is flattened at the pole, this north pole, this south pole, and bulges at the equator. That's why polar radius is less, but equatorial radius is more. In the same way, radius at other places, look at this, it's different. At different place, radius of the earth is different, but it is less at pole and more at equator. By observation, by different practical observation, and by different mathematical calculation, what is declared? The acceleration due to gravity, that is g, value of g is more at pole. It is about 9.83 meter per second square, and it is less at equator, that is 9.78 meter per second square. This value is more, this value is less. The reason is very simple. If radius at a place is more, like this, then g will be less, and if radius at a place is less, like this, then g will be more. Its value is different at different places of the earth, and that's why the standard value of g is taken as 9.8 meter per second square. We'll talk in detail in another video clip also about the relation between small g and radius of the earth. But here we can conclude that if radius at a place is less, g is more, and if radius at a place is more, then g will be less. Now, moreover, let's talk a little more also. If there is mountain at certain place on the surface of the earth, then radius at the top of the mountain is found to be more. Really it is more, and radius at certain place at the bottom of the mountain is less. That's why radius is more at the top of the mountain. That's why value of g is less at the top, but the value of g is more at the bottom of the mountain because radius is less. Now next point, g, value of g depends upon height from the surface of the earth. As we go to more height from the surface, the value of g goes on decreasing. If it is 9.8 at this place, then it will be less at height, maybe only 9 or 8, or it is more less at more height, maybe only 6 meter per second square. As we go up, the value of g goes on decreasing. Now let's talk about depth. If we go inside the earth's surface, then value of g is found to be less. Very interesting. G is maximum on the surface. If we go up, its value goes on decreasing. If we go down, its value goes on decreasing. It is maximum on the surface. Now the fourth point, it depends upon rotation of the earth. Earth is actually rotating around its axis, and because of this rotation, every object lying on its surface is also moving in a circular path. If an object is moving in a circular path like this, then a force acts on the body which pushes it away from the center. This force is called centrifugal force, and because of this centrifugal force, the attraction force of the earth, I mean to say gravity of the earth, is reduced then that of its real value. Because of this reduction of gravity, acceleration due to gravity also reduces. That's why rotation of the earth also affects the value of g.